Okay, so today is part 2 of the Analyzing Quadratic Functions lesson. And so yesterday we talked about those P's and Q's, like that. Today we're going to talk about this guy, the A. So this lesson can be a little confusing at times. So if you have a question, I just need you to put up your hand and I'll answer it, but I need a hand up first. Okay? So first we'll start with when A is positive, so it's greater than 0, right? So we know from yesterday when we see something like this and like this, we can substitute whatever our f of x in into there, right? So what would this equation be? Y is equal to hand up. Okay, and then this one would be 1/2 x minus 2 squared. Okay, so we remembered how to substitute from a function into an equation from yesterday. So in our graphing calculator, in y1, I'd like x minus 2 squared. So can someone put their hand up and tell me what sort of translation this would look like? X minus 2 squared. Kelsey? Yeah. So just like we have here. And then in y2, I'd like to see 2x minus 2 squared. Okay, and I'll put it up in my calculator too. And I'm going to make the line for my second equation a big fat one. So if you'd like, you can do that too. It might make it easier for you to see what exactly is going on. Okay, so what are some things, or does everyone have this, if they have their graphing calculator out? What do we notice about our second graph? Okay, yep, Josh? Same vertex, what's different though? Okay. Ah, the intercept has changed, excellent, perfect. So it's kind of got to narrower, that's a hard word to say. So it looks kind of like that. I'm not an artist, but everyone has a calculator, so. Okay. So if we go down to C, you'll notice it says, okay, so compared to the original graph, the number 2 in the graph results in a vertical, and I want you to cross out expansion and compression and just write the word stretch. Okay, so we're always going to be talking about vertical stretches. We're not going to use the words expansion and compression. So that's one less thing you have to remember. Okay? So we say that it results in a vertical stretch by a factor of 2. And like Justin pointed out, the y-intercept has changed. So Justin, can you tell us how it's changed? Yeah. Okay, I'll show you how to find that on your calculator, okay? So you go second trace, you can go value, 0. And so on our original, our y-intercept is at 4. And if you hit the up arrow, you'll find that on our new one, our y-intercept is 8. Okay. So we notice that the y-intercept doubles. Okay. So now I'd like you to go back to your calculator and change the second equation, so the equation with the big thick line, to be 1/2 x minus 2 squared. Okay, so we're just changing what's in front of those brackets. Yes, I did. Thank you, Josh. Yeah. Okay. And you can hit graph. Yeah, just like this. 1/2 x minus 2 squared. And make sure your 1/2 is in brackets. Pardon? It might, well, I think it should, but your calculator might think you're going 1 divided by 2 times x minus 2 squared. So it should work, but for safety's sake, it's better to have extra brackets rather than no brackets. Okay? So now we'll notice that our big fat line is wider than the original graph. So it now looks like something like this. Okay? So on our notes for D, we're going to cross this out. And we're going to write a vertical stretch. Okay? And so we say now that the vertical stretch is a factor of, what would you guess? 1/2. Exactly. So you can notice the connection between these numbers, right? And you'll notice so yeah, especially when it's numbers like 2 and 1/2. If it's something a little more complicated, you might want to pull out the calculator, but yeah, exactly. For 2 and 1/2, that's something that I hope you can do in your head. Okay, so we'll notice that the y-intercept is half of what it was before, right? So if you take a look at the note part, it says the general name given to an expansion or a compression is a stretch. All we need to know is that it's a stretch. You will not be asked at all about expansions and compressions. Okay? Okay. Lucas, are you having problems with the calculator? Okay. So if you go down to F, this is going to be like our notes. So maybe put some stars next to it. So it says compared to the graph y is equal to x squared, the graph of y is equal to ax squared results in a vertical stretch of factor a. And you can cross out expansion and compression and just write stretch. So if we scoot over to the next page, so we've talked about when y is greater than 0, right? So now we get to talk about, or not when y is greater than 0, when a is greater than 0. Now we get to talk about when a is less than 0. So negative a. Okay, so now in your y1, we'd like just x squared, and y2, we'll do negative x squared. Okay. So you should have something that looks like this. If you put brackets around your negative x, you'll only get the same graph as before, because when you square that negative number, everything becomes positive, right? So you don't want brackets in this case. So you should get something that looks like this. Okay, so this is called a reflection, and we say it's a reflection in the x-axis because it just reflects along that line there. So this year you'll just be learning about reflections in the x-axis, but later you'll learn about reflections in other axes as well. So, like the Y one, you got it. Okay. So let's fill out this chart so we have a nice little study tool. So our first one will be y is equal to negative x squared. And when we're doing a reflection, just a straight up reflection, does our vertex change at all? No. What about our max min value? Yeah, exactly, Kelsey. So the number doesn't change, it's still 0, but it does become a maximum now, right? So we write max 0. And our equation for the axis of symmetry equals 0. And then for the description, so on quizzes or in tests when I ask you to describe it, reflection in the x-axis. Okay. So for this one, we can do this one really quickly. Is our vertex going to change even if it's stretched? The vertexes? No, exactly, because when it's stretched by a factor of 2, it'll look kind of like this. So our vertex will stay the same. Our max value will stay the same, and it's a maximum because it's pointing downwards, right? What about our equation of the axis of symmetry? Same. And then we write it as reflection in the x-axis and a vertical stretch by factor of 2. So you'll notice if we're doing stretches and reflections, our vertex and our equation of the axis of symmetry does not change. Those only change when we're doing translations and we're moving it up and down and across and stuff like that, right? Yes, Josh? Nope, because like we can think of this as the negative being separate from that 2, right? The negative deals with the reflection, the 2 deals with the stretch. That's a good question, though. So she's asking, like, how much smaller is it really? Yeah. So what you can do is you can actually take some points. So say it's y is equal to negative 2x squared. So you can say, okay, x is equal to 1 would mean y is equal to negative 2, right? And then you would just have to plot a few points. So okay, x is equal to 1, y is equal to negative 2. Okay, like x is equal to 2 would mean y is equal to negative 2 squared. So 4 and then negative 8. So okay, 2. Okay, negative 8 because we're going negative 2 times 4, and then negative 8. And then you kind of have to just plot it like that. Okay, so it's kind of plot like 2 or 3 points on each side, and then you just kind of draw it in. Okay. Does that make sense to everyone? Okay. So we go down to E for our notes. So we'll do some stars, because this is notes worthy of a study sheet. Then we would write that an A less than 0, so a negative A, results in a reflection in the x-axis and a vertical stretch by a factor of A. Okay. So if you look at the next page, This is like mega notes. This summarizes everything that we've done so far. So if you have a study sheet, this is what you would want on it. This summarizes everything we've done today and yesterday. One thing we can do is cross out that expansion and compression because we're not concerned about that. And we'll just write stretch. So this part is what we've been done, or what we've done today. And then this is what we did yesterday with the horizontal and vertical translations. Okay? But this is like the I don't know, the go-to guide of analyzing quadratic equations. Okay, so let's do some examples now. So one thing I want to talk about before we get into our examples is for our a here, does that a belong to the x or the y? Which one is it changing? Exactly. So right next to this in our notes, I would like you to write the a next to the y. And then we're going to write the q next to it as well. Because remember, in that form we talked about yesterday, we want our vertical translation right next to the y. Yes, that's a bracket, not a 1. Okay. And x minus p squared. Okay. So we're going to be doing some moving of our a to the other side, just so we always remember that it deals with a vertical stretch. Because in grade 12, you learned about horizontal stretches. So if we always move that over, then before we even start grade 12, you won't get them confused. Mm-hmm. Yeah. Okay, perfect. Because all you're really doing is you're dividing everything by a, right? So then on the side of your y, it just becomes a 1 over a. Okay? And so we'll be discussing this as we go. So we'll show you in the example. So if this seems kind of strange, don't worry too much. Yes, Aaron? Never mind? Okay. Okay, so let's look at example 1, and we'll talk about this function. So it says, state the transformations applied to the graph which results in the graph of y is equal to 2x plus 4 squared minus 3. So the very first thing we want to do is get it in that form that we like so much, right? So we'll add 3 to both sides. So y. Okay. And so we have a y minus 3 because 2 minuses make a positive, right? But we want that minus sign there. Yes? Because it'll be like this, right? But then from yesterday, if you remember, we talked about how we always want this to be a minus sign. And so we know that y minus negative 3 is equals positive 3. But just for the way that we write it, and so this tells us a lot more about the y's of the graph than a plus 3 does. Okay, so we have y minus negative 3 is equal to 2 plus 4 squared. The next thing we want to do is move our a, right? So we'll divide this by 2. And we can divide this side by 2. Okay. And then all we have left to do is deal with this positive sign here, because we want this one to be a minus sign as well, right? So our last step in getting it in the form we want is y minus 3 is equal to x minus -4 squared. So when we look at this, right away we can tell what our transformations are. So we will say a vertical stretch by a factor of 2. So that's what we have there. So vertical stretch, factor of 2. And what about our vertical translation? Okay, let's have a hand up. Daniel? Yeah, so our vertical translation is 3 down because it's a -3. And I think it might have been Sam, say horizontal translation of 4. Okay, so when we're doing this, it's kind of nice because you're kind of working from left to right. You do, okay, stretch, vertical, horizontal. Yes, Justin. Okay, because if you look up here, it's 1/a. So it's still a factor of 2, but we just want to keep that on our y side because next year when you get introduced to the other type of stretch, you want them separate. You got it. Okay, so part 2 says, Marika and Curtis are discussing how to graph something without a graphing calculator. And they're arguing over which steps you do first. Marika suggests you do the stretch first, and then the translation. And Curtis suggests you do the translation, followed by the stretch. But if you flip to the next page, it says it right here. So you can remember SRT, stretch, reflect, translate. Okay, and this is the order you always do it in, unless the question says otherwise. Okay? So unless they tell you to do it in a different order, this is the way you want to do it. Yep, this year it will be. Yeah, just like it's always going to be vertical stretches this year. Okay? So, is there any questions over there, Jackson? Perfect. Okay, so in example 2, let's do both of these. So let's, for practice, write this in the form that we like to have it in. So if we have a stretch here that says -1/4, how would we write it in that form that we like so much? If it's 1/a. Okay, so we're getting like 1/4, right? Okay. So does anyone remember what you do when you see something like this? Yeah, you flip it, right? It becomes the reciprocal. Get -4a minus x squared. Because basically what you're doing is you're just multiplying both sides by 4. Does that make more sense? Okay? Yeah. Yeah. And then you multiply them both by -4. Okay? And so if we had to describe, what would we say about it? So first we have to describe, let's say, our stretches. So vertical stretch. by factor of 1/4. We don't worry about that negative sign when we're talking about stretches, right? Yeah. This is mostly just like practice because, like I said, you have to know how to keep them separate. And you have to know that that 4 belongs to that y. Okay? And then what is do we have a reflection in this one? Yep, there's a negative sign there, so that's reflection in the x-axis. And what about translations? No, exactly. No, there's none there. Yep, we got it. If A is negative, there's a reflection. Okay, so for B, this is kind of nice for us because our A has already been moved over. So when we write it in that form that we like you to know, all we have to change is this, right? So can someone put up a hand and tell me what our stretch is? Jackson? You got it. Vertical stretch. Factor of 3. What about our reflection? Yeah, Kelsey? There is no reflection there. Okay, and then we have a translation. Is it a vertical one or a horizontal one? Exactly. And how many units are we moving? 6 left. Right? Because there's no negative. Okay? Good questions, guys. Okay? So we're going to do example 3 now. So okay, so 3 transformations are applied in order. So we're working in the order they have to a graph. A reflection in the x-axis, a vertical stretch by a factor of 1/3 about the x-axis, and a translation of 7 units right. Okay, so the way we're going to set this up is I'm going to go, right, y is equal to x squared, and we're going to go through it step by step. So step 1. First one is a reflection in the x-axis. Exactly. So we're going to take our y and change it to negative y, right? And then so next to that, I'm going to write our new equation. So this is our equation at the end of that first step. Oh, this is an arrow. Okay. So our next step. Oh, sorry. Oh, wait. It does look good. Yeah. My YouTube fan club. Okay, so our next step is a vertical stretch by a factor of 1/3 about the x-axis. So how does our y change now? To 1/3 y? So our y becomes 3y because we do the reciprocal when we change it to the y side, right? We flip it. So we'll go in red. Negative 3y is equal to x squared. And cross that off. Mm-hmm. Yeah. Mm-hmm. Okay. And then the last step is a translation of 7 units right. So are we substituting something with our y or with our x? You got it. And what are we changing our x to? Yeah, x minus positive 7. So we'll go negative 3y is equal to x minus 7 squared. And so on a test or a quiz or anything, we always want to change it into our y equals form at the very end. So we go y is equal to negative 1/3 x minus 7 squared. Okay? So the next question is, what are the coordinates of the vertex of the final graph? So remember how by looking at this form, we can find those coordinates really easily. So how is our x being changed? 7. And do we have a translation in our y coordinates? No. So our vertex is now y is, or 7 and 0. Okay. And so the last part, it says, at the end of the 3 transformations, the point 1t is on the graph. And they're asking us to find what t is. So if we have this equation, this one here, and they say that x is equal to 1, how would we find t? Exactly, so just plug it in, because t is like your y, right? So, right. T is equal to negative 12. Okay, so our point would be 1 and negative 12. And this is something that we can actually test in our calculator too. If you have a question like this on a quiz or something, you can go, okay, negative 1/3 times x minus 7 squared. Graph that. Okay, we go second trace value, and we know that our x is 1. So we put 1, and we get y is equal to negative 12. Yeah. So that's a nice little trick to help you. It is. To help you test your work. Or if it's a multiple choice question, you would do that automatically, right? So instead of doing example 4, we're going to do a few things in the homework instead. So as a little gift to you guys, we're going to do some homework together. It is. All the snow has me in the Christmas spirit. Okay. So we're going to do 1C together. Okay, so 1C. Ready, Sam? Okay. So they're asking us to describe the graph, so that means we're doing it in words, right? But first we want it in that form that we all love so much. Yes, Josh? Y minus minus 1. Perfect. Yeah, because it's plus 1. You got it. Okay? The next thing we want to deal with is that stretch. So we know that's a 3/2 negative, right? And then what do we have inside of our x brackets? X minus negative 4. Perfect. So when they're asking us to describe how a graph looks, what we'd like you to do is kind of work from left to right. So the first thing we'll talk, just if you're describing it. But that basically is what it is. We deal with the stretch and reflections and then the translations. So it is. Yeah, just like an LRT, but with an S. Okay, so can I have someone with their hand up? Tell me what that stretch is. Yeah, Justin? Vertical stretch. Just 2/3, right? We deal with that negative later. So, vertical stretch, 2/3. By 2/3 about the x-axis. Yeah, always put that x-axis part. Every stretch we're doing is going to be about the x-axis. Okay? So, okay, so can someone tell me how to write a reflection or describe a reflection? Okay, so we know there's one. Yeah, reflection about the x-axis. And then all we have left to deal with is our translations. So let's do our vertical translation first. So our vertical stretch, we'll do it over here. So this is just for your notes so you know where these are coming from. Okay, and so our vertical stretch or our vertical translation is how many units? With a hand up, please, Josh. One down. Okay, and then our horizontal translation, focus, 4 left. Yeah, it'd be rude if we didn't warn you. Okay? Okay, for D, I'm not going to do the entire question with you, but I'm going to do part of it. Okay? Sam? So when we have it in this form, with our negative here, if this is a negative number, it's left, right? If this was a positive number, it'd be going right. Okay? Why is because, like, this is just like a prequel to something you're going to be doing next year. And next year, you have to keep yourself organized. So we're teaching. Okay, so for D, your first step that you would want to do, right, is you want to move that 12 over to the y side, right? So you go 2x minus 12 is equal to, or 2y minus 12, thank you, x minus 8 squared But one thing you'll notice is that we don't have our y in a bracket, and we always want our x's and y's in brackets. And so to do that, you pull out the GCF. Okay? See, this is why we're doing this part together, or else we'd have lots of questions about homework. Okay? So you always want to put your y in a bracket. Yeah, your translations are always going to be in brackets, so that's this and this. Okay. Okay. So this is all I'm going to do for you for D, just because from now, from here, you should be able to figure out the rest. Okay. I know GCF strikes again. Okay, so we're going to do one more homework question together. Today's just full of, they're all hard ones. I'm kidding. Okay, so this is kind of just the opposite of what we'd already done, right? Instead of giving us an equation, they're giving us words, and then we put it in an equation. So this is where we get our, okay, y is equal to x squared. And we start a vertical stretch by a factor of 8. So we go, okay, so what do we replace our y with? Right. For our vertical stretch. Okay. So if we're doing the reciprocal, 8y, right? And then we go, okay, so that's 1 8 y is equal to x squared. Okay. And actually, like, write it out with these steps. Mr. Trimble was telling me that this is pretty much a guaranteed diploma type question. So write it out step by step. Well, you don't have to memorize it. It's probably not going to give you these exact numbers. Okay, so the next step is a reflection in the x-axis. So, Sam, so what do we replace y with now? Negative y. And then we write it in our equation. Okay, and we can cross that off. Okay, so step 3, a vertical translation of 3 units up. Is that replacing our x or our y? You got it. Okay. And can I have someone with their hand up tell me what we replace y with? Yep, Josh. Yep. Okay, so remember it's 3 units up. Yep. Perfect. Okay, and then our very last one, a horizontal translation. Does that replace the x or the y? X. And what to replace our x with? For 9 units left. Hand up. Yep, that's it. Minus negative 9. Here, I'm just going to move this. Okay. almost. Okay, so the last thing is that we want this in that, no GCFs in this one. It's coming back to get you, Justin. All those GCFs. Yeah. Okay, so remember, as our final answer, we want it as a y is equal. So we go -8. Okay. Okay, so for homework, we're going to do 1 to 7. Plus 3 at the end. Because you're minusing, or you have a minus positive 3, so then you add 3. Okay? So homework is 1 to 7. We've already done a part of 1 and a part of 2 together.